Hi guys, today we are exploring factored form of a quadratic. So in our textbook we're looking at problem 2, this page 649, and we have a series of pretend students who are supposed to be writing a function that opens down and has zeros at 4, 0 and negative 1, 0. So let's see, on our first graph that opens downward, and we know that that's because there's a negative out in front, so we can tell that. And let's see, zeros at 4, 0, check. It's a little smaller, check. And negative 1, 0, check. So this one worked. Okay, moving over to this one over here. This one's opening upward. It's a positive 1/2 out in front, but it does have the correct zeros here and here. Okay. And I'm going to move down to one that's wrong. Okay. Actually, this one opens downward like it's supposed to, but the zeros are in the wrong location. Okay, they're not where the coordinates say they're supposed to be. So, what's the common theme here? Like, why are the ones that are correct, and why are the ones that are wrong, wrong? And I'm going to focus more on the intercepts than the upward and downward part, because that's what this section's mainly about. Okay, so this one has intercepts in the correct location, and what I want to point out is that this up here is a positive 4. Alright, but this down here says minus 4. So opposite signs. And up here we've got a negative 1, but in the function that works we have a plus 1. So the moral of the story here seems to be, let's check it in other functions here, okay? Positive 4 in the coordinate, minus 4 in the function. Negative 1 in the coordinate, positive 1 in the function, plus 1. Okay, and let's look at the one that was wrong. Okay, that had plus 4 and minus 1, so the signs seem to be in factored form that they have to be different. Okay, so if I was going to, let's come down to the bottom of the next page here, and it says use the given information to write a quadratic function in the factored form. So we can put in any a that we want that, you know, we have to pay attention to opening upward and downward, but we can use any value for a that we want. And notice that the formula for factored form has minus r and minus r. Okay, so r is just a letter that's going to stand for the x coordinate of the 0. Okay, I think the r actually stands for roots, because that's another vocabulary word that means the same thing as zeros and x-intercepts. It's related. So if I were going to write a parabola that opens upward and the zeros are at 2 and 0, I would write f of x equals, now if it's opening up, then in front of in the very beginning of my function, my leading coefficient should be a positive number. Okay, it's not being specific. We can be at it. It just says opens upward. All right, and so in factored form, we have 2 sets of parentheses, x and x, and we're paying attention to the x coordinates because the y coordinates are zeros, and that's a positive 2, so the formula says we use subtraction sign, so minus 2. Positive 4, minus 4. Okay, the parabola opens down for part B, so we're going to use any kind of negative we want. Could be a fraction, could be a decimal, could be just a negative sign, you know, with an invisible 1 coefficient. Okay, parenthesis, x. Now, The formula says subtract, but if I subtract a -3, subtracting a -3 is the same thing as adding 3. So that's why we go opposite signs. And x minus 1. Okay. Part C, the parabola opens down and the zeros are at 0, 0, and 5, 0. Opens down. Okay. Now, if the parabola opens down, or excuse me, if the parabola has a 0 at the origin, then I'm not going to put x plus or minus anything in the first parenthesis. I'm going to leave it like that. And in many cases, you'll probably find that they probably won't even draw the first set of parentheses. If there's nothing to go and add or subtract with the x, they probably won't put them. All right. The next section gives us a quadratic and wants us to find the zeros and then write it in factored form. So we will go to our calculator. X squared minus 8x plus 12. I'm going to look in the table. See one of my zeros. Aha. Okay, stop scrolling. All right, there we go. So let me pull this out. Okay, so one of my zeros is at 2, 0. And the other one is at 6, 0. So my factored form is going to be f of x equals x minus 2, x minus 6. Okay, part B. Clear this out, type it in. So my zeros are -2 and 0, and 5 and 0. Now this one is different because it has a leading coefficient out in front. It has this leading coefficient of -2. Well, when you're writing it in factored form, just carry that -2 down. X plus 2, x minus 5. Okay, so just carry your leading coefficients down. C, we have -x squared minus 4x so we've got zeros at -4, 0 and 0, 0. Okay, so factored form, f of x equals, now that negative sign out in front we carry down. I probably, I'm looking ahead and I see that we have one of my zeros at the origin. Probably going to put that first and put x without parentheses, just like I showed you a couple of minutes ago. And then x plus 4, like that. I probably would reverse it. That's most likely how you would see it, say, on a multiple choice or something like that. Okay. And the last one. Whoa, what happened? Okay, this one gives me zeros at -1, 0. My pen's acting up again. And +1, 0. So my factored form again, bring that leading coefficient down. X plus 1. Oh, I can't fit it. And x minus 1. Oh, I could move it over though. Okay. Taking a look at the homework, the first section, whoa, what happened? Is asking you to, it's gonna feel like reverse distributive property, but that's not like official terminology for that. Let me blow this up bigger. If you look at the example problem, 6x minus 24 is the problem. Now they show rewriting it and then showing 6 times x and 6, like they show the reverse distributive property happening. By the way, it's not called that, it's called factoring, and I will call it factoring from here on out. Basically, you're just asking yourself, what is the greatest common factor of your terms, and you're going to divide that out. So if I were looking at number 3, I would be asking myself, what is the greatest factor of 10x and 15? Well, that would be 5. So I can divide out a 5. If I divide 10 by 5, I get 2. Bring down my x, bring down my plus. 15 divided by 5 would be 3. So that's all you're doing in that section. In the next section, you're looking at an equation written in factored form, and you're just saying what the intercepts are, the x-intercepts. So you can see this said -2, so it was a +2, and then it's an x-intercept is a 0, so the y-coordinate's 0. -8, so +8. So if I were looking at number 9, my x-intercepts would be -4, 0, and +2, 0. Opposite signs of what you see in the parentheses. And the coefficient, the leading coefficient out in front really doesn't influence our intercepts when it's factored out like that. This next section is just like what we did in the textbook. Okay, so write a quadratic that represents a parabola that opens downwards. So f of x equals anything negative I want. Okay, that's a +2, so I'll write -2. It's a +14, I'll write -14. That's all they're really looking for in that section. In this next section, you're going to go to your y equals 2x squared minus 10x minus 48. See, one of my zeros, negative 3, 0. And you have to scroll. And 8, 0. Carry down your 2. X plus 3, x minus 8. And in this last section, you're just looking at the equations in factored form and figuring out what the intercepts would be. So in this problem, my intercepts would be negative 8 and 0. And, oh, 26 is tricky. Okay, yep. So, 26 is tricky, and I'm going to come back to that one in a second. Let me move over to 27. I forgot in class I did this out of order. Okay, so, oh, what happened? All right, here we go. We'll go back up to 25. No, I don't want 25 either. Well, I guess they're all like that. Okay. So, in 27, we see one of our zeros is going to be easy to figure out. It's going to be positive 14 and 0 to go with this set of parentheses right here. However, this set of parentheses right here is not, it has more than just x. Like we can't find the zeros of a function from factored form if it isn't fully factored. What I mean by that is when we were in the beginning of the homework, we had problems like this, okay, and we factored something out. In this case, we're going to factor out a negative 2, and we're going to get negative 2 parenthesis x. Now, if I'm factoring out a negative, that's going to change my sign, and 4. And I'm going to erase this and move it down. Okay, so you really can't find intercepts unless you have in the parentheses an x on its own. Okay, so then I can do my zeros. 4, 0. And 14, 0. So 28 okay, x plus 16 is fine. It's got an x by itself. But this says 2x plus 16. And I only want this to be an x. So I'm going to have to factor out that 2. Now, we're going to factor it out all the way to the beginning. Okay, it's all multiplying, so the order doesn't matter. So the leading coefficient should be in the beginning. So if I factor out a 2, I'm left with an x. If I factor a 2 out of the 16, that's plus 8. Okay, and I didn't factor out a negative, so I'm not changing any signs. So now my zeros are negative 16, 0, and negative 8, 0. Okay. All right, 26. Said we're going to come back to that one. Let me start this one over again. Okay, so x plus 8 is fine, but this second one is in a weird order. It says 3 minus x. So we're going to change that around to be negative x plus 3. Okay, well, like I said, you don't want anything in front of, you don't want any kind of coefficient or sign in front of your x's within the parentheses for factored form. You want that out. So that means I'm factoring a negative out of both of those. Now, it doesn't impact the x plus 8. That's a different parenthesis. That stays the same. Okay. This negative x, I factored out the negative, so I'm just going to have positive x. Positive 3, if I factor out a negative, would be minus 3. Okay. Now I can write my zeros. Negative 8 and 0, and positive 3 and 0. And guys, if for some reason you're really not confident in your answers, plug them into your y equals and look at it. So let's say I was not confident in what I did. Okay, I could go to y equals, plug in, clear, x plus 8 3 minus x. Okay. And you could look at the graph there. Okay, negative 8, 0, and 3, 0. Okay, so yeah, I have the right zeros. And then if you wanted to further check, did you factor that negative out correctly? You can see that my blue function turned red because they overlapped each other because they're the same function. Okay, I want to point out, do not think that it is okay to, let me pull this actually out. I don't want anybody walking away from this conversation looking just at this part and thinking that, like, say 5 minus 3 is the same as 3 minus 5. Like, I can just take any subtraction and reverse my numbers. It's not that simple. Okay, we cannot do that. This would be a positive 2. This would be a negative 2. Okay, so how come it looks like we can do that? Because don't forget, this also had a negative sign out in front. Okay, so when I reversed things, a negative, now if I put a negative over here and I multiply by a negative over here, then I do get a positive 2. So it's not, I just hope nobody walks away thinking that 3 minus x and x minus 3 are the same thing, because they definitely are not. Okay? Alright, I hope this helps. Have a great day. See you next time.